SmartLipo is the laser machine which is mainly used for melting fat tissue. But usually it is used with manual suction technique. And we could not tell that SmartLipo does for all in terms of efficacy. We developed the technology that transfers ordinary laser light to plasma one, which has better thermal effect on a specific area. And it has been using for herniation of intervertebral disc. I happen to think about different application this technology to melt fat tissue now and would like to introduce you about this technology called Plasmalipo. I don't have any experience in this field. So, I am learning through Dr. Schaefer who started SmartLipo secondly in the US. And has been treating many cases from all around the world. He thought that the original parameter of SmartLipo is not very satisfying in the results and raised the output of laser to 10 watts from 6 watts. Upgraded the width of fiber to 400 micron from 300 micron. This machine he improved is called Laser Lipo. I applied the same parameter to the ND-YAG laser made by SLT Japan, because its specification is changeable to Dr. Schaefer's Laser Lipo. And I compared the effectiveness of both machines Laser Lipo and Plasma Lipo. For this comparison, I adopted the diode laser, Plasma D3980 made by Gyses Medical. This D30 maximum power is 30 watts in spite of the machine weighs not heavy for easy handling. Left picture is an image of the normal fiber which is applied by laser. As you see, laser light travels in straight line. This is one of main specific characteristics of laser. If this laser is used for melting fat tissue, thermal damage will be going forward only. So we modified the tip of the fiber to dome shape from flat shape, as you see the right picture. While the light is passing through the fiber, light starts to repeat diffused reflection. And when the light is bumped out of fiber, it is diffused shaping a circle centering the end of fiber, as you see the picture right below. It means that it can melt all direction of fat tissue. The light diffused in a circle lost the character, monochromatic light, and changes its character to visible light, which has broadband wavelength from 500 nanometers to 800 nanometers. Plasma light diffuses in 360 degree as a ball shape, and so there is a risk of skin damage if its temperature is raised too high. I inserted a dome-shaped 400 micron fiber into the fat tissue upwork and placed temperature sensor 2 mm forward, 1 mm side and 3 mm side from the tip of the fiber for measuring the change of temperature. Please look at the right side. This is the movie after radiation 300 joule with 10 watts each. I compared with the left laser lipo, which raised 10 watts from the original output, and 400 micron fiber by Dr. Schaefer. Laser lipo's temperature of 2 mm area from the tip reaches up to 120 degrees Celsius, but in Plasma Lipo case, temperature was not increased more than 81 degree. In the experiment for Plasma Lipo, 1 mm side from the tip of the fiber maintains 81 degree as well, and temperature of 3 mm away from the fiber keeps less than 45 degree. Plasma Lipo is much safer than Laser Lipo and of the same energy and the same condition, because the temperature of surrounding tissues had been kept low in Plasmalipo test. Then, how about the efficacy of these two cases? Left side is Laser Lipo and center is Plasmalipo. The testing for Laser Lipo, fat tissue had a little damage, transparency gets high, but we can hardly tell fat tissue is melted. The testing for Plasmalipo, the area is widely getting more transparent, and we can tell 3.5 mm by 3 mm area from the center of fiber is melted surely. The picture on the right side is the result after using 600 micron to boost Plasmalipo's effectiveness. The output energy was applied same as in the left and middle cases, 300 joule with 10 watts. Transparency and range of dissolution are become much stronger and wider. In actual operation, the optic fiber is moving back and forth. So we also radiated under same condition while the optic fiber moves 1 cm in 2 seconds. In the Laser Lipo case, the temperature rises up 82 degree like the graph on the left when the fiber is passing. We measured the temperature of 1 mm side of optic fiber. But in Plasma Lipo case, the temperature goes up to 63 degree only. Although the temperature is maintained at the point lower than 63 degrees, its melting area was wider as you see in this picture. When I was looking for a patient based on test result, I could meet a volunteer who is one of our staffs. She is 28 years old woman and wanted to have the treatment on her upper arms. The energy applied is 1500 joule with 15 watts. Local anesthesia was applied and no suction after operation. This is the picture after a sole treatment by Plasmalipo. There was no complication except internal bruise.